In this video, we're looking at some typical problems. So for the included angle, we want to look at the angle that is in between the two sides, or the angle that hooks the two sides together. So that's going to be the angle that's at N. So angle MNP is the included angle. Sets up a SAS pattern. For 2A, we want to classify whether we can say that they're congruent, write a congruence statement, and the positive theorem. So with this one, we can see the reflexive. We have the altitude congruent, and that sets up a side angle side pattern. So the two triangles are going to be congruent by side angle side. And if we go A to C to D, we have to also name the other one A to C to B. So they're congruent, and it's A to C to B. Okay, looking at the next one, we can see that we have an angle side angle pattern. So the two triangles are going to be congruent by angle side angle. And we have R to S to T matches with Y to X to Z. And again, we can trace out that it's an angle side angle pattern. So RST goes with YXZ. Looking at C, with the way the triangles are marked, we have side angle, and that's not going to work for us. It would only work if it was the right triangle. So that one can't be done the way that it's marked without doing more work possibly. If we look at D, we can see that D is a classic side pattern, that HJ is reflexive and shared between both top and bottom triangle. So these triangles are going to be congruent by side. And if I'm going H to I to J, I have to name the other one H to K to J. So we have triangle HIJ is congruent to triangle HKJ, or JKH. Oh, the two sides are twisted, so it's JKH. Look at the next one. We have angle side, but actually that's hypotenuse leg because we have a right triangle. So those two triangles are congruent because of a hypotenuse leg. So ABC is congruent to DEF. And if we look at F now, we get the vertical angle there at M. LMO is congruent to NMP. And then we have the two sides marked as congruent. And then we have the angle side as our pattern. So those triangles are going to be congruent by angle side. If we're going to go L to M to O, we have to go N to M to P to name the congruent triangle correctly. Looking for number 3, we want to find the missing values. So best way to do that is just to mark the corresponding parts on the triangles. So they're telling us that EF and RQ are going to be congruent to each other. Also angle E and angle R, angle F and angle Q, and angle G and angle S. So I'm going to mark all those with corresponding marks. And then also need to do the sides. It takes a little bit extra time to do this, but overall it makes it easier to do, I think. So we end up with 2x plus 1 matches with 3x minus 2. Let's finish putting the matching sides in. So EF goes with QR, QS goes with 5, and RS goes with GE. So we can say 2x plus 1 is equal to 3x minus 2, and simplify, and we get x is equal to 3, I believe. We get x is equal to 3. So once we find out that x is equal to 3, then we can plug in to the different ones that they give us. So GE is going to have a length of 7. EF is going to have a length of 9, and RS is also going to have a length of 7. And now we can fill in the blanks. So QS matches with 5. So 5 is the length of QS. The measure of angle S is going to be 30 degrees. That came from triangle sums in the left-hand GEF triangle. And X is 3, we found.